Afternoon, delegates, ladies and gentlemen. I'll just sort of hope to start this off, and I've been asked to be mildly provocative, and I'll try and do that as quickly as I can. I've been asked to answer sort of three questions, and I'll sort of close one of the three first, and then I'll deal with the other two. The first one, of course, is what kind of disaster risk information infrastructure will be required for planning and decision making, and I'll deal with that in some detail later. But the key question there is, before you can start planning for a system that addresses these kind of questions, wherever it is, at the city scale, at the sort of sub-national scale, national scale, or regionally, you have to be clear what you're doing with it. What are the objectives that you're trying to meet? And I'll come to that in a second. The second is a sort of trick question, but having worked in this area for a long time, I can quickly try and answer it. And that is whether current infrastructure investments around climate risk are adequate or not. And I say it very simply, I can answer that very quickly. They aren't, because climate risk is very poorly understood and integrated into processes at the moment. We know that from the numbers. If you look at climate finance, adaptation, which is what we're considering a lot here. What is in the climate space is sort of deals with physical risk as opposed to transition risk, which is the mitigation side. Is less than 10% of the financing, and one of the core reasons for that is that resources don't flow into a sector in which you're actually not able to aggregate risk information. So I would say, apart from not having good enough framework to deal with this, in the climate space we do not have adequate risk aggregation. This is the biggest challenge we have in the adaptation space, and this is very critical because, as many of you know, we are pretty much headed towards a 1.5 overshoot. We may be hitting a 2-degree overshoot in the next decade or so, and that's quite important for the disaster risk community. So that's a quick answer to the climate question. And the third one is, what kind of data do you need? And there again, it depends on what you're trying to do. So, before I go into answering the first and the second question about what kind of infrastructure, what kind of data systems that you have and you need, I'll basically say that in this room, or within the countries in the room, we have solved many of these issues individually and in fragments. So if you're able to bring stuff together, it can actually work, and I'll give you two concrete examples. CDRI is actually putting together the first global assessment of disaster risk as far as infrastructure is concerned. It's a systematic piece of work. It's been building on 20 years of work that many of us have been doing in the risk space now across the UN system and other such things. So that's an aggregation. But 20 years ago, I led a process which looked at one of India's provinces at that particular point of time. Our current Prime Minister was the Chief Minister, and pretty much all of the questions that we've been hearing, I guess, over the last 2 days were addressed across key infrastructure elements. This is 20 years ago. The state of 60 million people was broken down into 226 entities. We built a macro model which linked it to macroeconomic processes. We were able to look at risk compression, investments across all critical infrastructures. The only thing that we didn't do at that time was look adequately at climate, because the climate models were not good enough and downscaled enough to deal with that. And pretty much all the hazards we're talking about were dealt with, including others that we're not talking about just now, which include chemical accidents. So it's possible to do it. It's been done in this country before, and I've seen it, as many as you have, in various locations. I know that certainly in China, where I've seen this thing happening, in many parts of the EU, in a somewhat more fragmented way in the US, this kind of stuff is possible. So it's possible, this has been done. It's just that we have to bring together these models and these processes, connect it with ongoing things that are sitting with Sendai, and of course community-based processes. So let me step back and give you a context of what I was saying in terms of how do you scope this question, how do you scope this problem. So we are, the globe at the moment is, got an economic size of about 100 trillion. That's what global economic output is. So 8 billion people produce about 100 trillion worth of output. You divide one by the other and you get a per capita, whatever it is, global world product of about $12,500. India's as a benchmark at about 2,600. So even within the G-20, you can see there's a huge variation. So dealing with inequality in terms of resources, in terms of context, is quite important. So the cost of a loss of life in a $500 per capita economy versus a $50,000 per capita economy is going to be different if you use conventional systems of fiduciary risk assessment. So I'm just giving you, a benchmark number that's there. So $100 trillion economy, growing at about 2.5%, fine, assuming that it will. of course we know that shocks are coming, means that by 2050, we're going to reach about $185 trillion, fine, as a total economic size. Why am I giving you this number? Because the current estimates that we're putting together, and I think the CDRI report is going to be quite important in this, speak to the fact that currently, if you add both buildings and infrastructure together, the compression you get in economic output is about 1%. So basically, in a $100 trillion economy, you're losing about $1 trillion, a little bit more, 1.1 trillion, if I remember the number correctly, as far as that's concerned, fine. Your growth is 2.5 trillion. So if you look at the ratio between what you're losing, and this is losing in the first order, these are direct losses, these are not indirect losses. This does not take into account losses for nature and agriculture and things like that, which we don't know how to measure, or biodiversity we don't know how to measure. Those are quite significant. So your incremental growth is 2.5 trillion. You're losing $1 trillion or more at the current point of time when we know the climate is coming. That's to give you a sense of scale of where we are. But the more important number in some senses for a lot of the discussions we've been having here is the actual size of the exposure in the global economy. So, $100 trillion economy actually has exposure, if you add buildings and infrastructure, if I remember the number correctly, about 550 trillion, fine? Of which 2/3 is buildings and 1/3 is infrastructure. So I think the immediate question that hits you, not in terms of the large number itself, is in your information systems, how much of buildings and how much of infrastructure you want to put in there. So some countries will want to focus on infrastructure because that's a core challenge. Others will want to focus on buildings. But in actual fact, whether you're an OECD country or not, especially with climate coming in and dealing with all kinds of other questions, you have retrofit issues in buildings. In other parts of the world, you're building lots of new buildings. So I think the core question is, how do you build these information systems to address both? If you have resource limitations, which one do you pick first, depending on what your economic priorities are and what the implications are for, on life, on livelihoods, on economic output, and a whole range of other processes down the line. So I think that's the thing that we have to get somewhat clear. So like I said, $100 trillion of output, $550 trillion worth of assets at risk, of which about, infrastructure is about 175 odd, maybe 200, depending on how you count it. The rest of it is buildings. And the buildings are of various shapes and sizes. Now, if you just look at that, at those numbers themselves, fine, just to give you a sense of scale, at the global scale. And the reason I'm saying this here is, we know the G-20 is 80% of global output, fine. 2/3 of people, 80% of output. So effectively what happens in this room determines how the global economy is going to work, how we address risk at global scale, how we mobilize markets, structure public and private investment to make this happen. This is really, it's a big question which will make a difference, for the rest of the world as far as that's concerned. So in that, I think there are 2 or 3 things that are important. The first thing, like I said, is 1/3 infrastructure, 2/3 buildings. How do you bring them together? Because especially given the world that it is, we now have a world which is 55% urban, going to become even more, fine? 80% of economic output comes from urban areas. So what do we have? We have a risk environment that is global now, fine? We know about that, especially for hydromet risk, for seismic tectonic or for geohydrological, meteorological risks are sort of across the whole landscape as far as that's concerned. So in that, if you look again at the exposure, 1/3 is geohazards and about 2/3 is climate, okay? And as far as we know it, of course, I'm not talking about exposure now, I'm just looking at the hazard risk side, fine? As far as we know it, the geohazards is not going to grow dramatically, fine, in terms of hazard risk. But the hydromet is going to grow very rapidly as we go from 1.1 to 1.5 to 2, and if we get to where Paris is, we're at 2.7 to 3.2. So just in terms of the risk exposure on the hazard side, cyclonic storms, sea level rise in the long run, drought, flooding, etc., all the the nasty things that come with too much water, too little water, and polluted water as far as that's concerned, we're going to see an expansion of the hazard risk side. So when we're thinking ahead, depending on where we are, if you're a littoral country or you're looking at something like Mumbai on the seacoast or you're inland and you have drought, you have to be relatively clear about how this thing is going to play itself out. That's, I guess, the second thing that I'm trying to say. So look at the exposure, fine, and then try and see where the hazards are actually playing themselves out and how they will change over time. And the big numbers, of course, are interesting, but it gives you a sense of relative scale. And of course, in large countries, whether it's Brazil or South Africa or the United States or the European Union or India, you'll have tremendous diversity because, geological context changes, hydrological context changes, etc. Those become fairly important as far as that's concerned. So Given that breakup, one-third infrastructure, two-third buildings, one-third geohazards, two-third climate, how would you structure a system that would start responding to these things? Because the investment is going to come, fine, or it should come, and there, I guess, three things that are there. One is the current stock and how you deal with that. So let's say in the global north, the questions are often of retrofit, whether it's to reduce, hazards to earthquakes, like in California or, pretty much, many, or in Japan for that matter. In other places, it's a question of how you building new build infrastructure. But in between that, because we're in an urbanizing planet, the issue is how do you structure your urban areas, fine? And in that, how you plan, how you organize things in space, in which both land and infrastructure markets are very, very critical. The speciality of that is quite important. And we know in that context that at the current point of time, if we have across the world to meet the Sustainable Development Goals, we have a significant infrastructure gap. And that infrastructure gap, depending on how you count it, is in the hundreds of billions of dollars a year just to deal with meeting the outcomes of the goals. On top of that, you add risk, which is coming to you from geohazards, kind of known, and the global models will show us that, and increasing risk that will come to us because of climate, and climate hazards becoming even more intense. And you'll see the geographies of that will change, especially with climate change. So it's a question of how you deal with what you have just now, how you deal with what you should be having, because you're in sub-Saharan Africa or South Asia or other parts of Asia, and effectively you're bringing hundreds of millions of people into cities and other places, and you concentrate risk in some senses. So how do you deal with that? And then finally, because infrastructure ages, and it ages quite quickly, even if you built it up relatively quickly like China is, how do you deal with the problem of aging infrastructure as it goes out of its life cycle, especially because when you're building very quickly, you do not build in a very resilient manner. You don't have the investment, you don't have the standards, and there's no political push to make that happen. So that's, I guess, one of the core questions that we have. You have to design an information system or a data system or a modeling system that not only takes into account what has been there in the past, but how these trends will change in the future. Obviously, I'm making very, very broad generalizations here. Any economist in the room will say, what the hell are you talking about? But I'm just trying to give you the big picture of how we have to think about these questions, because technically we know how to do this stuff. It's been done before. It's not a big issue as far as that's concerned. So there's the question of the investment gap to deal with the delivery of services and places to live and places to work, fine? And there's a question of how much incremental investment will require to make it more resilient, fine? That's just the service side. Now, having said that, I'll step back even one step even wider than that and say, look, we have three sort of what I would call a trichotomy in the risk space, which we need to grapple with in trying to define and address these questions in terms of risk, fine? Because the numbers are big. These are trillion-dollar problems. The investments are also of the order of tens of trillions of dollars, because your savings rates are that much, and this in a sense drives growth, drives employment. We know that post-COVID, etc. The first thing is the hazard risk landscape is spread across the world. Fine, it's diffused. And especially as we're getting into more hydromet-led hazards, it's going to be even more diffused. We wouldn't think there were huge problems in the Arctic and the Antarctic and high altitude areas earlier, but now these are going to become, basically the risk landscape is going to be extremely diffused and be across the world as far as that's concerned, fine? Which means that we need to have very good geographic information of how risks is spread across the landscape. And I think that's where the partnership across countries in G20 is very important. Most of us, I think between the countries, you have most of the satellite assets across the world, because we can measure things that we never knew that was possible to measure in the past. You can even measure at the moment how much groundwater declines. You can do lots of things, and I model. So in July, we're having a summit in Berlin, which is looking at exoscale models. So instead of doing stuff at 50 by 50 kilometer scale, because of the computing abilities we have, we're going down to 1 kilometer by 1 kilometer on the climate side, which means suddenly the disaster risk models and the climate models can meet somewhere in between, fine? So the risk landscape is going to be spread across the world, fine? And with climate, at least in the first order, you have to have information, I would say, ideally at the 1 kilometer by 1 kilometer scale, and we have the technologies and methods to do it not only from satellites, but potentially now with digital technology on the ground, because sensor costs are becoming much lower. The second thing, which is quite important to pick up on the climate story, is we're going to have to capture carbon, fine? And the capturing of carbon by growing forests or doing something under the ground, etc., is going to be a significant part of the impact as far as vulnerability is concerned across the world, especially in environments where water is scarce, land is scarce, and there are a lot of people. So there's a new emergent second order set of risks that are going to come for our attempt to try and deal with climate. Some of them may be maladaptive or not, that we have to think about, because if we don't think about them, we won't measure them. If we don't measure them, we won't be able to integrate them into the frameworks. So come back to that point. Basically, hazard risk is going to spread across the landscape. But on the other hand, risk is becoming increasingly more concentrated. Pretty obviously, because we're becoming more urbanized. Basically, the risk is where the people are. People are typically along coasts, in littoral areas where the water is, and around cities. So risk, the rest of the risk, especially the exposure and vulnerability, is becoming more concentrated. So that means that the models that you have, the information systems, have to cope with a diffused hazard risk landscape, but a higher concentration of vulnerability and exposure at the same time, which means you have to work across the settlement systems, across the economic systems, across the network infrastructures to understand the third thing which has started emerging. We all know that from COVID, we know that from all the work that's been done in UNDR, etc., across the world, and that is we are really experiencing systemic risk. Right? Systemic risk happens when different elements of the system, risk is cascading or compounding through that system that's there. Right? And how does this systemic risk appear in economic systems? It appears in the multiplier impacts of a direct loss. So you have a flood somewhere, it might be in Pakistan, it might be in Thailand, so many examples of it, or Fukushima, and what you have locally is not what you get at the national level. So we're dealing with three things at the same time. A risk landscape that is becoming much more diverse. We have good technologies to understand that, but we have to collaborate because there are multi-hazard risks. I mean, there are multiple hazards that are there at the same time. You have to know what the frequencies are like. You have to be able to sort of model them and whatever. The vulnerability is very critical for many of our countries, including, I would say, for countries in the global north, because service levels and infrastructure levels have declined very significantly. Whether you see, the sort of recovery, the sort of infrastructure program in the US or what's happening in Europe, especially as you're trying to do a just transition and the other infrastructures at the other time. And the key question then in the larger risk framework is, how do you reduce systemic risks by reducing the impact multiplier that is there? So if your risk is of the order of $1 trillion, the impact multiplier, as we estimating just now, maybe twice that size. So then you're losing $2 trillion of $2.5 trillion of growth. We don't actually know those numbers, but it's important for us to build the models to be able to understand whether it is. Because that is the rationale for actually working on questions of governance, risk governance, financing, etc., because that's the multiplier impact that you see across the economy or across sectors in some sense. So what are the responses? And I'll close very quickly with this. The response, of course, is to build resilient infrastructure. Right? That's one response. And we have a fairly good idea about that. There are global standards and many things like telecom and power systems, etc., etc. But typically, resilient infrastructures work along one sector or one set of economic activities. There's a sector, and you're able to reduce the risk for that sector as far as that's concerned. There again, we have to be careful about the mix of what happens in terms of output loss, because that's a very significant thing in a growing economy, or especially newly developing economy. Capital raisement cost, and of course, something that we often forget, and that is the asset life. So when I'm coming back to where the model should be like, where the data system should be like, if you don't have an understanding of, first, where the people are, second, where the economic activity is actually happening, third, where your assets are that actually enable the economic activity and the output and the services where they are in a geographical manner, you can't address the connection between vulnerability exposure and the hazard risk which is changing. That's absolutely critical. So the question is, how can we economically do this at the lowest possible scale? We know that all the fiduciary models do this, but they're only available for certain geographies. How can we expand that process in a public data frame for the rest of the world is one question. But that's only looking at the question of resilient infrastructure. The larger question, which is more difficult and we don't have good answers to, is if you're talking about building infrastructure for resilience, as different from resilient infrastructure to enable social development, human development, nature-based solutions, and protecting nature and macroeconomic stability, we have to understand the linkages between the sector and those infrastructures, which means that as a community that works on risk, or the fiduciary aspect of risk, we have to talk to the people who are working the economic side and the people who are working the finance side. Because the investments are not going to flow, or let's say the investments go to places where you have the best multiplier gains that you have, whether it's in terms of output or in terms of job creation or otherwise. And we don't have the frameworks for that. And frankly, because I work across this in different parts of the world, we don't actually have the right people in conversation. We now have some of the finance community in conversation with the risk community, intermediated by people in insurance, but we don't have the macroeconomists and the finance community and the risk community talking to each other, because it's only when you're bringing the macroeconomists inside, the central banks and finance ministries, etc., that you'll be able to look at the connection between different forms of risk, different forms of infrastructure, and the synergies, and in some cases, serious trade-offs that you have. So what I'm saying is, we need to build what we have. We've had most of the stuff in place. We have to do that systematically, because unless we're able to get risk information, we can't pool risk. If you can't pool risk, we can't finance it, either from the national scale or using various forms of capital, whether DFI capital or otherwise. And at the other end, if you're not able to get risk at a fine-grained enough kind of frame, you can't address it from the community, from the local inside, whether it's early warning or response or rebuilding, etc. So we need fine-grained models, but there's obviously a trade-off between trying to do everything and doing what is possible in the time that we have. So prioritization is critical, fine, but we have to have a framework that addresses each of these questions in very simple, straightforward terms, starting with how much output we have, how much investment actually goes in, where the risk is situated, how it's partitioned between buildings and infrastructure, how it's partitioned between geohazards and climate, how much of it is vulnerability-led, which is a lot of the global south, how much of it is exposure-led, which is things that you may or may not be able to do something about. And then hazard modification is something that becomes extremely expensive. We know that from the climate side. I think in other sides also, even to do hazard modification on geohazards is very expensive. So we have a clear idea of what kind of interventions are possible and can be dealt with. So I'll stop there. I hope I didn't kind of sort of overstate my case, but I'll leave it there. Thanks so much.